Hello. So let's begin our series of lectures with the introduction of the content. First, we will discuss a bit what complex systems are. Then we are going to try to understand what this means for communities, networks, and our transition to sustainable development. And then we are going to try to understand the systems of innovation and different types of innovation that are part of the discussion, especially open innovation and innovation for sustainability, or otherwise said eco-innovation. Then a separate chapter, the fourth, will be dedicated to how human systems are related to natural systems. Then we go into methods. We try to see how we can establish the priorities, the options, and in relation to this we discuss a bit how we can develop some scenario sets and how success will result from this. After that, we have to discuss a bit the idea of experimental platforms, or platform for experimentation of different solutions. And this is related to the process of social learning and the advancement of a team or a project up a learning curve. Finally, in the last three lessons, we will deal with the technology embedded in human systems, especially technology-human interfaces and techno-economic paradigms. Then we come back to how knowledge and action can be linked in an efficient way, and we discuss a bit the role of computer models for that. And in the end, we summarize the process of technology development, and we try to understand how to measure the progress in this process. Now, objectives in this series of lectures are three. First, I want to provide a framework for orientation for you. That is, I want this series of videos and slides to be a sort of backbone for you, to which you can come back anytime to try to understand better a concept, obtain some links or references, and make sure that you keep your track on what matters. Second, I want this to be a toolbox, methods for creating new solutions in practice. So first was understanding, second, a toolbox, what to do and how. And third, I want to provide here some methods for evaluating the progress of your ideas into practice. So this is part of the understanding and of the action part. The final result of this series of lectures will be a PowerPoint presentation which you will make containing up to 20 slides, minimum 10 slides, in which you make your own summary with your own words of the lessons, all of them. Okay, of course, it's not allowed to use my own slides, but you start from there. At the end, I evaluate your learning and I give you a mark based on the quality of those summaries. During the live meetings, I will help you to make this, but at the same time, you have to take responsibility for this. So it's really your tool that you're developing for yourself, and I want this to be related to the projects that you're working on or your ideas. Now, going into the content, you probably remember from our live introduction the idea that sustainability science is a recent phenomenon, and that we have this issue of fragmentation of disciplines which prevents science from generating really efficient solutions for society in terms of sustainable development and transition to this. Here I summarized these roles of science in 3 graphs. In the first one, A, you see a temporal evolution of sustainability science. Well, the short idea is that it's really started with the Brundtland report, and then it got some speed with the Agenda 21 in Rio de Janeiro. And what happens is that sustainability science gradually managed to become a sort of recognized field of research of itself. I give a bit more detail on the next slide. But here I want to make also the point at B and C in the diagrams that, interestingly enough, the main contributors to sustainability science in terms of traditional disciplines are biology, social sciences, and engineering. That is the green, the yellow, and the light blue corners. They are roughly a third each of them, with some others important contributions too. But an important point here is that during the last decades, this composition, these percentages of contributions remained roughly the same, and you see in graph C. That means that we should expect also in the future that the main contributions to sustainability science will come from engineering, biology, and social sciences. In terms of contribution by traditional disciplines, we should also know that there is a fast growing number of publications in sustainability science now. The percent of distribution of contributions are based actually on which journals host the articles, scientific articles, and as a highlight, it is interesting that the percentage of contribution stays the same, even though the number of publications is growing exponentially. Now, if you want to understand more about the process of science itself, you can start by clicking on the link that I provide there on the bottom, and you get more details. This is in a very prestigious journal, Proceedings of the National Academy of Science of the United States. Now, in this next slide, what I want to highlight is that there was a key moment during the year 2000. Before that, different disciplines were contributing to sustainability science, but really in terms of what they knew to do, each of them, so separated from each other. During the year 2000, there is a really moment, a unification of science, not in terms of creating a new theory or something, but in terms of interaction between researchers. Here on the graph A and B especially, you see 2 different lines, red and blue. These represent different clusters of researchers, meaning that every research article is published by a team of authors. Now, when the same authors are always publishing again and citing other authors that are from the same field, for example, if they are engineers, they only refer to other studies that are in engineering, then you don't really have an interaction between different type of researchers working on sustainability. But during the year 2000, what happened is that there is an accelerated process of mixing of these teams. So these sociologists, engineers and biologists and so forth continued to do work, but they started to do more work with people from other fields, not just their own field. And that is the moment where we can consider that the sustainability science became unified as a field. Again, it doesn't mean that we have a unified body of science. This remains to be done, and it's a big challenge. However, an important reason for optimism is the fact that contributions from researchers around the world are coming into sustainability science. So you see, it's not only a few countries. It's from Australia, China, Europe, North America, and so forth. This is very important because we are supposed to work together on the same common issue that is related to our own planet. Now, in this next slide, you may remember these two figures from our live introduction. And what on the left is represented is a cluster analysis of sustainability science, meaning the number of publications and the keywords. You will see different circles which represent different domains, and the bigger the circle, the bigger the number of articles, so the more work is done in that field. Different circles overlap with each other, meaning that there are some interactions between sciences. And you may notice that some of these disciplines are purely academic, like ecological economics, for example, and others are very applied, like health, fisheries, and so on. This is the reality, and the main purpose is to create a really coherent body of knowledge between these disciplines. So this is what we start from. And of course the final objective is to achieve an equilibrium between what we know about our planet and what we do on our planet, on our technobiosphere.